Welcome everybody to what is going to be a fantastic session presentation today. I'm already looking forward to this one. I was going to, like I like to do, ask if there's anybody new with us that would like to introduce themselves. It's completely optional, so okay to stay quiet too. But we always like to use this organization, this group, as a networking opportunity, so you can get to know other people in the group and potentially collaborate, work together, and learn from each other. Anybody new that would like to raise their hand and do a quick intro? Or if you've got anything new going on that is new and different, projects, work, otherwise, we'd love to hear about what you're up to. All right, just checking. Now, how about events? Is anybody got anything interesting on the horizon or come back from events lately that we would want to know about? I'm going to pull up the Vertical Flight Society website. We've got Forum 81s coming up May 20th through the 22nd. That's in Virginia Beach. And then in a couple months in July, the weekend before the EAA AirVenture in Oshkosh, is the Electric Aircraft Symposium. That's a great one. I went the past couple of years and really enjoyed that. And then looks like in September, we've got the European Rotorcraft Forum in Venice. I should be going to that one. Is it?
Yes.
I feel like the tax deduction is a good idea. Is anybody planning to head to any of those? All right. Well, hopefully we can get a group together to meet up in Venice. That seems like a lot of fun. But Oshkosh is always amazing, and that's going to be a great one. All right. We've got, I'm going to just pivot to the good part here because we've got a absolutely fantastic speaker and presentation set up for today. As I'm making the introduction, I might ask everybody to turn off their cell phones, and I'm going to do that in a minute as well. And then also mute, just so that we don't interrupt our speaker. I would like to introduce Nick Lappos. So he is an aerospace engineering graduate of Georgia Tech and a Lockheed Martin Fellow for Advanced Technology. He joined Sikorsky originally in 1973, where among many other roles, he was program director for the S-92 helicopter. And that program ultimately earned the Robert Collier Trophy, which is a really big deal in aviation. As the chief research and development test pilot, he logged more than 8,000 hours of flight time in 70 plus different types of helicopters. He holds more than 30 patents and, believe it or not, 3 helicopter world speed records, which I would like to hear those stories sometime. He was previously a vice president for Gulfstream Aerospace and a senior vice president and chief technology officer for Bell Helicopter. Nick's also served as chairman of the Vertical Lift Consortium from 2012 to today. Nick's a decorated veteran of the Vietnam War, where he flew Cobra helicopters. And today he lives in Cedar City, Utah, with his wife, Mary, in an off-grid solar home of his own design. And Nick has showed me the design for this home. It is unbelievable. If you're into architecture, you owe it to chat with him about that. But I don't want to digress. Nick, with that, the floor is yours. Take it away.
Thank you very much, Andy. Let me go ahead and share here, and we'll go through this. This is a presentation, but it's a free-for-all. Please, if you will, I think the group is small enough. Just speak out. Tell me what you see that you agree or disagree with as we go along. These are just discussion items for what the future might look like, and I hope you understand that we'll shape it together. So it's conceivable it may not be as I'm describing, but it will be what a consensus creates as the best way to meet the challenges of the future. It's based on these 2 reports, the Advanced Air Mobility Report from AIAA and Advancing Air Mobility Report, a national blueprint from the National Academy of Engineering. I happen to be the chair or co-chair on the committees that wrote these reports. I do provide a link for these reports at the end of this, so you're certainly welcome to download and I think they're very good sleep aids, quite frankly. Just to illustrate though what we're talking about with this, see if I can, there we go. This is a map of Manhattan Island from 1811, and that is the street plan. Something to bear in mind is the black at the right end of the diagram, the southern end of the tip of Manhattan, is the only thing that existed. Everything else was a plan. And what it does illustrate is if you plan it, they will come. And every street, avenue, every fire hydrant was all surveyed, so the city simply filled it out. And what I'm proposing, I think, is that we think about this for our national airspace and get ready for it so that when we have the number of machines we think will be there, we have a graceful system to allow it to operate, to make good business, and to stay safe at all times. The task force for the AIAA had two major areas, and we're not going to talk about the first one, which is what do we do about certifying these vehicles, and what about the technologies of the vehicles? We have some thoughts on that, but that's not what this is about. And I must tell you, of the things that are hard to do, that's the ones being attacked by the most cash. If you look at the amounts of investments that exist. So it's conceivable that that's going to self-sort as time goes on. And you can see the tremendous progress that machines are making in that regard. The second one, though, is what do we do with these machines once we have them? And I think what you're going to find is we do not have solid plans for the airspace of the future. The FAA has some great stuff going on, but they are busy running the safest and busiest air transport system on the planet, and therefore probably not in a position to think about how to dynamite it and build the next one. And what we're proposing here is how to dynamite and build the next one. So we're going to talk about that in some detail, and also embrace the FAA to recognize that they are the ones that have to be satisfied. So anything we're talking about, they'll be sitting around the table with us, and they'll be saying yes or no. But I think that the creativity that could occur when we get such folks as NASA, as the VFS, as AIAA, and as the operators of the machines around a table, we'll get to much better ideas than those that come from the government alone. The FAA is showing good conservative wisdom today. The plans that they're making are the minimum disruption on today's system. So we have to recognize that. But I must tell you, if you think about a future system where you want to have the most throughput for aviation assets, would you build routes? Would you build lanes and have fixed approaches? Or would you let vertical lift machines simply self-sort themselves? Think about that and think about what you do if the slate were clean and if you were not channeled by the ideas of how cars drive on a highway, because it's not highways. The sky is different. And we think, the committees think, that there are different ways to handle this. We'll talk about that a little bit. Something I must point out is the FAA has said, hey, detect and avoid. Self-regulation of the systems is going to mean that the aircraft avoid each other. And we think that is a major prescription for a problem in the long future. If you think that you can build a machine that carries CVS prescription drugs, that has the visionics necessary to see everything around it and avoid them, then you've just raised the price of those drugs. It's entirely possible that the detect and avoid visual system on board these machines might cost $10,000, $15,000, $20,000, raising the floor of what can be serviced with these machines. We don't think that's where the world wants to be. We don't think Walmart wants to deliver you Snapple by having a detect and avoid system that costs $25,000. And the idea of having routes and corridors, as I mentioned too. In fact, what happens is many areas of the United States are inaccessible, and they probably will not suffice in the long term to serve the packet express and other items that will be coming with the advanced air mobile assets. What we think is a set of needs that might be described is a drone accessibility to every U.S. address. There's a NASA report out written by a very good NASA engineer who uses the word door to door. And I'll steal his phrase, door to door. In fact, what we think is going to happen is you're going to have a world in the future, 15 years, 20 years, where the mother gets off the phone with the doctor at 3 in the morning because the doctor says the prescription will be on your doorstep in 20 minutes. And it is. Or that there's a fire engine that circles the city and looks down and sees the IR signature of a fire before you called it in, and they attack the fire on the spot. I want you to think about that world would be like if you had somebody had a heart attack and the machine comes out from the hospital doing 70 miles an hour over the city, therefore only seconds away from virtually any address in the city, and lands on the front lawn to take the passenger back to the emergency room. Now, what we think is all the vehicles in such a system should report their position, their identity, and their intentions, and the system helps sort things out. If you think about detect and avoid, it's possible to have a sensor on the machine that sees everyone else. Or how about a network that knows where everyone is, and the network tells every machine where everyone else is? The network is the sensor. And if you think about it, we live in such networks today, and I'll describe them a little bit further on in the pitch. And those places were really worried about security over a ballpark, a presidential inauguration, an airport. It's entirely possible to have separately monitored and validated traffic measurements that's added to the system, that validates the system, if you will. We'll talk about that. And real-time airspace allocations based on priority, public need, and usage. In other words, a 777 comes down the ILS at Teterboro and has the right of way. But once they land, the Package Express comes behind them and fills in the neighbors until the next ILS is shot. And then that Package Express stuff runs away or parks on the ground and waits for them to pass over. And everything is validated by the system I described. And the drone autopilots could also be directed by the ATM system. It's entirely possible for drones to fly in formation with each other. We could build those hooks in pretty simply into the autopilots that can be bought on a drone for 35 bucks in the mall today. We think that we're moving toward a place of societal change where a lot of the goods that we now rely on trucks and drivers to bring, that goods could be brought by aerial vehicles at probably a fraction of the cost per mile to carry the goods. Think of what a FedEx truck costs. The truck, the driver, the insurance, and the fact that that truck moves at 11 miles an hour as it goes from address to address. Driver gets out, puts the package on, gets in, goes to the next one. And yet it makes money. What would happen if you had a drone that carried 100 pounds worth of packages, 10, and flitted from address to address, dropping them off? How many dollars per mile that drone costs? It drops the price tremendously and raises the accessibility tremendously. And think about doing that for police and fire and ambulance as well. Anyway, that's a sort of a picture of the future. And I'm probably pretty good at standing on soapboxes, painting a future, but also recognizing it'll only be built when all of the stakeholders together decide how it should be built. And here is just an illustration of what can happen. This is Phoenix. Now, if you look carefully at the slide, you can see where the city grid is. And all of the red are the airport traffic areas and the ILS approach paths. Those are the areas where today the FAA would say no drones. I'm sorry, you can't have a drone there, which means all the addresses underneath those red circles cannot be serviced by the system I'm describing. In other words, today's airspace will not allow the Package Express system to work. We don't think that's possible. We think there's another way to do it, and we can talk about what that is. Detect and avoid, there's a typical detect and avoid system right there. And you can only imagine what those boxes cost. You can only imagine what detect and avoid does when we hand it to every air vehicle. You'll never have a pizza delivered by a piece of flying gear that has $20,000 worth of detect and avoid equipment on it. There's no economics for a pizza, believe me. The GAO said the same thing. I covered the links on these reports. The FAA has to improve its understanding of how drones work in the National Airspace System. It has to look at the business requirements and the mission requirements. Think if the FAA designed the VOR airway system and didn't think about the slots in the airlines. It just built the system and said, okay, airlines, see if you can use it. And that's not what happens at all. The FAA very wisely runs slots, has them even auctioned off, and understands that the business underneath the airspace system is exactly why the FAA is there. The same thing has to happen today. I don't know if you realize this, but Amazon has committed to building their own aircraft. And Amazon is intending to fly something in the neighborhood of 500 million packages a year, starting around 2029. Walmart is committed right now to 1.5 million customers served with Package Express in the Dallas area in the next year. So it's coming. And the inexorable business of carrying things around, the things that we do with society, that business could propel us. And I'll offer up a simple calculation. Amazon Prime members spend $1,500 a year each. There are 110 million Prime members. The dollar volume of revenue for Amazon Prime alone is about equal to the entire United States airline system. In other words, when it comes time, and this would be very similar, think about the telephone system, think about computers, think about cars. Did anyone imagine when Ford built his first Model Ts that there would be a car in every driveway, there'd be 300 million in the United States? Would anyone ever imagine that? And what would you imagine then for the number of drones that operate to deliver things to us and to take us to other places? Why do you have to drive to an airport when a drone could land on your front yard or on your rooftop or on a neighborhood helipad and take you to the airport and do it for the cost, probably the cost of a taxi cab? Anyway, that's what the GAO says as well. And there are about 6 GAO reports that talk about that. And here's a slice of what the world might look like. And I must admit, this is only my notion. And so please poke as many holes as you want in it. I expect to have some folks laugh at this. But I think you're talking about a city, one mega city like New York or Chicago or Atlanta or San Francisco. One mega city could have 10,000 drones operating in it. It would not be hard to imagine. How do I get that number? Please look on the left-hand side. Every day, 125,000 trucks drive onto Manhattan. Every day, New York City receives 1.5 million package express items. Every day, the New York City emergency system has 4,000 ambulance calls. So if some percentage, 10%, 20% of these are handled by this airborne system, there are the numbers you're talking about. And Andy, you said maybe you were talking about 10x for the number of flight vehicles. I think it's entirely justified. And so I must say this too. When we talk about the future eVTOL world, we think of the Archers and the Jobies. That's that top piece of the pyramid. That's the tiniest slice. I believe replacing helicopter air taxi with efficient air vehicles will happen, but that is certainly not the mass. It's important and necessary, but by no means where the real future will be. Underneath is the real future. And just think about that, please. And I invite you, somebody should throw a dart at me right now. Come on, it's time for a debate about this. So I'll stop for a second and let somebody pipe in.
There's no debate. You're absolutely right.
Thank you. And what really says too then is, how do we handle this traffic? This is not going to be handled by, you must stay 400 feet below. You must not fly anywhere near airplanes. This is not going to work. So what would work? That's really the question. And just to drive the point home, here are the mega cities in the US, and I'm not going to go into any great detail about it. I think that what we lack in our industry is a bottoms-up analysis of the business of air transport as it applies to door, and what that business should look like, and then therefore what the aviation system should look like that supports it. We're going backwards. We always do, by the way. It's a lot more fun to talk about the machines and the aerodynamics than it is to talk about the business of what they do. Future business needs set the requirements. Drone accessibility at every address. Few permanently fixed corridors or airspace. If you make it permanent, then you just denied something. I believe that most digital systems, anyone here get in line for the internet? When I put a URL in the internet, do I have to wait in line? Is there a highway? Is there an off-ramp? It's completely open access. All the vehicles in the system report the position, identity, and intentions, and the system helps sort it out. And key areas are monitored separately. I'll talk about that as well, and so on. And this is what it might look like. I just drive the point home that each vehicle carries with it probably something that's not too different than your cell phone and costs about the same. If we do this right, we don't have Honeywell or Northrop Grumman design the box. We have Cisco Systems or Microsoft design the box. And it's based on cell technology, quite frankly, and has a lot more redundancy, a lot more self-checking. Yeah, okay, it's 2, 3, 4 times more complex than a cell phone, but it is in the order of magnitude of a cell phone. And I'll stop here because this is the place that has the most fun for technologists to figure out how to answer the mail. But we have to ask them to do it. We need an RTCA project immediately that starts to lay the groundwork for where this is going to come from. And then we're left with this. They're your corridors, but they only exist temporarily. The corridor opens when the airplane needs it and closes behind the airplane. The airplane is protected in a bubble, a sterilized bubble. But when the airplane's not there, then the other vehicles are free to use that airspace to do what they have to do. And the system watches it all. Now, what happens if you have a bad actor? Let's suppose one of those vehicles has a bad navigation system, or let's suppose one of those vehicles was built by somebody who's really nasty and doesn't want to be part of the system, but they're going to fly in it anyway and do something bad. What happens? And the answer is that we can build a system for the bad actors, and this is one of them. Matrix Space actually has a radar system that within about a half a mile can detect everything from a pizza on up and plot it all perfectly in 3 space. And if you think about the radar system that does this, that could be one of the feeds into the network. So the network has an automatic validation system, and this radar system would then correlate itself to the network's reported positions, find every target in the network, and then find the ones that aren't reporting or are inaccurate and reporting the wrong things. And therefore you have sort of a self-check, a validation. And this system is not terribly expensive. My belief is you could put several of these in the city, and certainly one at every airport, and maybe at big sporting events and national events where you're worried about bad guys doing something horrible.
Brandon, did you have a comment?
Nick, I'm familiar with some of these sort of millimeter wave systems.
Yeah.
I'm doubtful that, and so my pushback on the sort of half mile detection and the smaller detection systems in terms of range, their ability to properly inform a command and control structure is challenging, right? Because the first thing is so a bad actor gets detected, but there's an entire command and control structure that needs to be implemented. And a half mile at, even at smaller drone speeds, not enough, right? Like, I mean, the thing is going to do whatever it's going to do anyway. I mean, you'll have some good data in arrears when you look at the accident. But I don't see some of these millimeter wave systems being enough, especially at the lower end of the cost spectrum to realistically form a network that could inform it. But I could be wrong though, because
I don't think you are. I think if we look at where we are in today's state of the art, it would barely be usable in such a system, and therefore their goal is to stretch. These people are talking about more than a mile. I made it a half mile because I don't know if I believe that they can see a 12-inch drone at a mile. That's a heck of a target. So the point you're making is a very valid one. I must point out this doesn't have to be terribly cheap, because a city might only need 10 of these. And so if you think about the actual investment to sterilize the airspace upon which millions of people depend, maybe it can be expensive enough and proper enough to do the job I'm describing. In any case, if we don't have this, we revert the system back to where we are today, where there's not really effective control. And I'm not sure that we're going to build a system and leave that off. I think
great points, Nick, and an excellent presentation. Sorry to interrupt.
No, you're not at all.
Presentation.
I must tell you this too. Whenever somebody comes up and says, "Hey, this might not work because of this," that's golden. If you don't carry that to the table and answer it, you're going to build a flaw in the system. And it's going to bite you later. I gave a speech the other day to one of my the folks I'm mentoring, and I said, "Listen to the naysayers, because they write your requirements." So thank you for that. Anyway, a drone show proves my case. You have 2,000 or 3,000 drones, all operating within a meter of each other, all turning the lights off and on to make this globe, for example, or a dragon. And that's because a lot of the drone shows are run by Chinese, so there's always a dragon involved. But they show you that if you can build a drone show, why can't you run the UAVs and EVs around a city the same way?
Is that a question you want to answer?
Yeah, I guess it is. Or someone tell me why it's not an apt metaphor. Yeah.
Well, the first thing that comes to mind, and I guess I'm probably putting my foot in my mouth here, but a drone show is you are from the beginning designing where each drone will go, so it's almost, it's kind of like synchronous. You know what's going to happen, and you're then setting them up. Whereas, different operators all trying to operate in the same space is very asynchronous. You don't necessarily know. In fact, I'll give the example. You go to a restaurant and you just sit there for a few minutes, and people come in clusters, and yet they all came in different cars, but it's feast to famine. And I think you'll see the same thing in the skies, unless there's some controlling, something that controls a little bit that says, wait a minute, we can't insert anymore right now. You're going to have to wait a little bit, which is kind of what ATC does at the moment. So I think there's probably some sort of, and maybe it can all be done, remotely, self-administered, but you're probably going to end up with some need to minimize the congestion like they do on freeways or other things so that not everybody gets on at the same time.
That's exactly right. In fact, you've fleshed out a couple of areas that are soft in here, but are still part of what we're talking about. The idea, for example, that the drones would separately talk to each other and self-sort. And there would be limitations. If there are too many in an area, you'd have to tell people to hold or wait or even go sit on the ground somewhere. That's exactly right. And all that is part of what we see. A drone show is only the illustration that you can make them all fly around and not bang into each other. It does not answer the mail for the whole rest of the question, which is a very complex one. It also says, Michael, that we might want to have you on the team. So hold those thoughts, okay? Any case, a couple of examples. The bottom one is the best one. Every day, FedEx moves 6.5 million packages and knows where they all are within a few meters. The data is not the problem. On the days before Christmas, FedEx handles 20.5 million packages and knows where they are within a few meters. So the data is not the problem. The data systems are not the problem. It's whether we want to build a system that properly gathers the data and then puts it to use. And Google, when we use Google Maps and Google Traffic, all Google Traffic does is simply look at the speed of the folks that are reporting in. And if the speed slows down, it makes the road red. So it's rather simple. Once you have ubiquitous data, you do marvelous things with it. So what we're really saying is most of this involves having every air vehicle tell you what it's doing and where it's going. And by doing so, we end up with a broad picture, and now we can figure out how to manage the issue. Now, what's the call to action? Number one is we need a strategic plan, and we don't have one. The entire AAM system is dependent upon good businesses that are trying to build their vehicles, folks who are trying to put them to use like Walmart, and the FAA trying to figure out how to make it all work safely. My suggestion is we should all gather and talk about what the future state happens to be. Think back to the map of Manhattan, and we need that. We need that for the National Airspace System. And once we do that and set some goals for it, with some watch out points, as a couple of comments here are made, all very valid, we end up being able to build a plan that might work. Now, a plan should also carry with it the funding necessary so that we can build this navigation system, if you will, the National Airspace System that has the necessary hooks in it and the necessary software. And I do recommend that the system not use traditional avionic routes, but use fairly standard US and foreign data systems that are very adaptable to this. And the second part of it is that we have to design the NAC itself, get a team together that does that, get a project that starts to work for the RTCA, define a module that would be on all vehicles. And I could picture the module would have increasing complexity. So a Pizza has a module of a given complexity, and a 777 has one that's much more complex. But each one of them carries with it the necessary hooks into this NAS system. And that's almost my get off the stage. This is the actual page from the National Academy's report. And please note the second bullet is really the same thing we're talking about here. Shared airspace, many classes of vehicles, separated by networking technologies. We recommended that back then. And that was the year 2020. This is a list of some of the sources. And I offered up to the two main reports are the first two hits. Then after that, it's just some stuff that I found and shoveled around. Husni Idris from NASA had a very good set of points that he made in a couple of publications where he talked about the idea of door-to-door. And so I stole his phrase door-to-door, and I want to give him credit for it. And here are the GAO reports that talk about this as well. Drones, action needed to better support remote identification, federal efforts to address unauthorized drone near airports. All of these talk about areas that I've either touched on a little bit or should have touched on. And I invite you to take a look at them. And there you go. So now we're ready for spirited debate.
Let's get the brawl going, Nick. The gloves are down. You've thrown
Yeah,
down
yeah,
the
yeah.
gauntlet. I will tell you that, and I'll show my age in a couple ways here, but I'm old enough to remember uh, starting to use like an Apple II, and we had to learn how to use a floppy disk drive. And so getting data around was on us. We had to have that piece of equipment. And at the time, when there wasn't anything else, we thought it was the best. You know, I can haul around a whole bunch of data in a very small space, but obviously that doesn't make a lot of sense anymore. I don't keep my data on a USB drive or a disk or anything like that. It's slow, and I don't want to have to dig around for it. I can go to any computer and pull up my files on
Yeah.
Google or Apple or whatever. It's cheaper, it's faster, it's more convenient. That's somewhat of an analog to our airspace system, where when I started flying, it was, you know, based on terrestrial based systems like VOR towers, and we had roads that, you know, connected the dots, and that's how we got around. And it worked great, absent anything else. But now that we have GPS, it you know, that it doesn't make any sense. We don't have to go A, B, C, D, E. We can just go A to Z right now. And this is really what you're talking about. And it makes complete sense. But making that change is hard, and it's very hard when you're talking about an overworked, underpaid, and underappreciated governmental entity like the FAA. To ask them to add on more tasks to what they're already doing with what they've got it's a big ask, because they're in a heck of a position. Danny, I'm seeing in your notes that you had some similar comments and analogies, which I thought made a lot of sense. Um, do you want to chip in with those?
Sure. Thanks, Andy. I just, it occurred to me as you were speaking, I was very intrigued by the idea of throwing out everything and starting fresh and new, but then recalled the old analogy or the story of the fact that the width of train tracks are based on ruts in the road from ancient chariots, and wonder, you know, are we kind of condemned based on all of the pressures, political pressures, funding pressures, pressures between the West and China, to go with something incremental, incremental innovations, as opposed to, you know, the best solution, disruptive solution. And even if the will is there, how do you operationally go from something to something brand new without either parallel systems, which I could lend all sorts of potential problems, or shutting down the old and switching to the new, the big bang approach, which never really works very well.
You know, you raise such good points, and all of them are entirely valid. As a technologist who dealt with the idea of R&D and of disruptive technologies throughout my career, I have embraced exactly what you've talked about. And by the way, the way the chariot wheels ended up with the train track widths, did you know that the United States had 4 different train track widths until the end of the Civil War? And then all the train companies got
No.
together and said, you know, we can't have rolling stock that is not fit on the rest of it. Doesn't work. I want to have a standard railroad car. Think of container traffic today, right? And do you know how long it took the United States to switch the gauges to all be equal? I know you're not going to believe
No.
this. Please, you know the history guy on YouTube. Please look up the history guy gauges. 36 hours. They actually laid the
Oh.
separate set of tracks. Everyone did. So they had the standard gauge, and then they had their old tracks too. So many of the railroads in the United States had 3 tracks for a period of up to 6 months.
Interesting.
And then when it came time to
Never knew
change,
that.
in 24 hours, 36 for the worst case, but in 24 hours, most of the rolling stock in the United States was all standard gauge. So your point is very
Well,
valid, but it also says, and by the way, not one governmental authority was involved with that at all. It was all business. It was all folks who had a vested interest in doing it right. My suggestion is that we have to
Interesting.
gracefully move because you don't want to stumble. You never stumble with a 747 full of people. That's the last thing on earth. But what you don't want to do is do what I remember. I was on one of the highways, the Hutchinson River Parkway, in up above in New York City, and it was winding, but sharp S turns. And I asked my dad, "Where did the S turns come from? Why did they do this?" And he said, "Well, when they laid the highway out in the late 30s, there were graveyards around, and they couldn't disturb the graves. They couldn't get permission from the families to dig folks up, so they ended up making the curves in the highway. Well, those cemeteries are gone now. The curve is still there. What we don't want to do is build something with the artifacts of the old, truncate the ability of the new to do a proper job. So it's a delicate balance. And Denny, I invite you to be part of what we're talking about too. But when it comes time for us to have a discussion of this.
Hey, Brandon, did you have a comment?
No, I'm just synthesizing all the data at this point. First of all, Nick, great, just simply fantastic presentation. It's rare, and honestly, it makes my heart a little happy to have an operator, give a realistic presentation. Like I get a little tired of the pie in the sky sort of, sort of stuff. So thank you. I guess realistically, so Andy, I'll disagree with your analogy that the GPS system versus maps. Like GPS just tells us how to better navigate a currently inscribed system that's a two-dimensional sort of navigational array that is overlaid on top of planet Earth. The three-dimensional array is much more interesting to me. I mean, we've seen it over the years. Now that we have GPS, sort of ubiquitous travel being the way to go, and I lived that transformation from shooting double ADB approaches in the mountains to Vortex to GPS, even curved approaches right now, which is just absolutely fantastic, and slowly moving towards a more efficient way to do air travel. Practically speaking, I do see it like now that I'm thinking sort of in real time, which is dangerous in front of this group. But, I definitely do see a much more efficient way to travel around. It requires very, very careful flight planning on the front end. So submission of flight requests or flight plans from point A to point B. Airborne, it requires a lot of network, ironclad network communications between each aircraft. And I think properly done, it could really offload a lot of ATC. I still, I had a startup idea where I was going to take all of the ATC communications and synthesize those into each cockpit through voice recognition and some AI data learning into actual instructions to different pilots that they would then acknowledge, and the ATC would get an acknowledgement back, and it would be much more efficient than using all this low data rate sort of voice communication. But in any case, there is a lot of I think there's a very interesting future that you're talking about where, again, practically implemented, and your transformation piece is very important, where you can't go from A to Z right away. There's a lot of room for efficiency, and both you and I have seen this through thousands of hours of airborne flight. So anyway, all that to say, great presentation, thank you, and lots to think about.
Thank you. And all those thoughts will be constructive toward getting to this new place. There's no doubt we want to be at a new place. And I must tell you, if I were operating an air taxi helicopter today and someone told me there'd be 2,000 drones wandering around Toronto and they're all moving at 50 knots and I'm visually responsible for separating from them, I would be scared to death. I know.
Not possible.
Haven't I done that? Haven't you done that enough? It's impossible.
I've tried to shoot them down before. I can barely find one that I'm looking for specifically, let alone the 49 other ones that are just randomly in the same airspace. Yeah.
Exactly. And not only that, look at the horrible accident in Washington and the fact that those two well-trained crews were all on visual. The airline, by the way, everyone talks about the helicopter hit the airliner. No, the airliner hit the helicopter too. And in fact, the airliner was on a visual segment. They were all responsible for visual separation. They didn't see each other. How is it that two large flying machines didn't see each other? We know the answer. We know what that city looks like with all the lights, and we know what an airliner looks like when its lights are on. It doesn't look like an airliner. It looks like a bunch of lights.
That's a really frustrating thing for me to hear, that the visual, the acknowledgement of visual separation can be extended into those crazy environments. I've been there before. It's not realistic. I mean, they should have accepted visual separation in a sea of 1,000 lights at night on goggles where your field of view is like literally 20 degrees. I have probably 500 fighter hours on goggles, and I've flown low level strike attack missions on goggles, and it's the most dangerous thing you can possibly do, and
Yeah.
that was frustrating to hear, and so there's some cleanup to do at the same time.
And meanwhile, they've got the FAA saying the entire future world to be detected and avoided. And you're responsible for seeing the folks around you. I'm sorry, we've gone past that. Haven't we gone past that? I mean,
Yes.
isn't it time? And by the way, if we do it for the air vehicles, what about ground vehicles? Why aren't the cars locked into each other so these guys can't pass me at 95 miles an hour, weaving in and out? Why don't we all just get on, if we have to be on a highway, get on and have our cars lock into a kind of like a train, and you move along at nice speed, and you get off safely and all that. Anyway, I could go on from this because I'm a technologist who says, once we have the technology, where else can we put it to use?
Well, you and I share the same sort of interest. I firmly think maybe it's 500 years from now, they'll look back and like, look at these crazy humans 500 years ago. They would rip past each other, going 100 kilometers an hour in each opposite direction, separated by 12 to 15 feet.
Right.
All under manual control, no automation whatsoever. In bad weather on slippery conditions, they'll actually laugh at us, thinking like this is crazy that anyone survived, right?
How's that go, Dad? I want to be a pilot, but I'll be a crappy pilot. Well, why do you want to be a crappy pilot? Remember you told me about Pete? He was a great pilot. He went in the side of a mountain on a dark night. Yeah, remember that? I don't want to be a great pilot. I want to be a crappy pilot, live for a long time.
Yeah, that's right. Learn from your mistakes.
All right. So if you hear a call from us to come join us and come give your thoughts, this is what we're talking about. And it wouldn't be a bad idea. VFS is a very great part of all this. And I must tell you, the infrastructure of the heliports and of the electric charging and all the other fun stuff people talk about pales in comparison to the infrastructure requirements of the air traffic management system.
Well said.
I just watched a documentary about the 1939 World's Fair, and at the General Motors Pavilion, they had a Futurama exhibit. And one of the things that they said was going to be happening in the next 20 or so years was that there would be radar-based separation of cars on highways. And that was in 1939, and we're sneaking in on 100 years and still haven't quite pulled that off. We're getting there, but
and we murder 40,000 people a year in cars. You'd think somebody would look at that and say, could we make that just 10,000?
Yeah, and that doesn't, when there's an air incident, that doesn't come up. There's a false equivalency that says, well, listen, despite the fact that we didn't publish any of that on the news because it happens so frequently, a car accident, we're just going to talk about this aviation accident right now because one happened, and it's so rare that that's news. So we're going to talk about that, not mention the other ones, which puts us and the FAA in a negative light unnecessarily so, or at least unfairly so.
That's right. I also think though part of the public's buy-in for car accidents is that they feel like they're in control. I have the wheel in my hands, I have the brake, I have the gas. So therefore I can do something about it. And I'll often ask people, do you really think when you're on a 2-lane blacktop and a guy is passing by and there's 110 miles an hour of differential velocity and that truck is 2 miles from your bumper and that guy just got out of the drop in, do you think you're in control? Come on, give me a break.
Yeah, that's right. People are in control of themselves, but they don't realize that's irrelevant given the traffic around them and the lack of control of what everybody else is doing.
Exactly.
Oh, this is, I mean, you're preaching to the choir here. I think about that on a daily basis, especially with kids. And, they're all packed into the safest car that we can get, but it's at the same thing. I mean, the number of variables is impossible to control in a 2-dimensional sort of roadway that, again, we're talking, 100-mile-an-hour closure rates between the two vehicles with minimal separation and random people, half of which have lower than 100 IQ by definition, right? really frustrating for me. The air is is a much safer environment, having spent a lot of time there.
Yeah, yeah. And
For
by the way,
sure.
I believe that firmly. The idea of trying to design a car to drive through a five-way intersection in Boston with yield signs and pedestrian crossways, as opposed to the cleanliness of an air trip from point A to point B, all of it pristine, all of it we define who's going to be there. Our job of automating is much better. And I must tell you, we can automate the emergency procedures in a helicopter because it's so very kind. The helicopter can land.
Oh, but come on.
Automated.
The five-way intersection is a whole lot more fun for a few of us.
I know. And it's also fun too for me when I taught my daughter how to drive it. I had to sit in the other seat and watch her go through it. Yeah, in
So
fact,
Nick,
yeah, please go ahead, Eddie.
well, when we think about interfacing with our overworked regulators, what how should we be thinking about that? You know, we're asking them to do what they're doing really well already today, and then asking them to do uh, quite a bit more. How do we get their attention and get them to
I used to have
add this
that's
to their plate?
it's a great question. First one is they can't do it with today's budget because they're not budgeted for it.
Bingo.
And I must tell you too, they're also not staffed for it. The FAA is an operating organization. Imagine the state police of the state of Connecticut, and you ask them to lay out the next highway system. They're very good at regulating today's highway system, perfect at it, but they're not designing future systems. So the answer is we have to do it and bring the FAA in and look at them every time we make a decision, and they nod their head yes, and then we do it, or they say no, and then we fix what they said no about. They must be in charge of the end product and buy it off, but we can't ask them to invent it. If the US Post Office had invented email, you'd be licking stamps and sticking them to your computer screen.
This is so perfectly said. Like I couldn't agree more. There needs to be a practical reality, and you can't just ask people to do stuff and organizations to do stuff, right? And
That's right.
this is my frustration is that, well, I think if we start at the beginning, there are certain functions of government, right? That they need to uphold the law, respect, enforce property rights, maintain some sort of road infrastructure so that people, can traverse. I agree in a very small government, not a huge, large one, but this might be another thing where government support is adequately, again, and I am definitely not an advocate of throwing tons of money at pie in the sky ideas. Space is another one, but regulation of and improvement of an air infrastructure and air traffic infrastructure such that people can more efficiently move around the planet is akin to kind of a road infrastructure. And typically governments around the world have taken on that responsibility. So proper government funding and support of a very smart and practical plan to move forward from an air traffic management improvement perspective makes sense to me for something that should receive government support. Because you're right, the FAA can't, it's too busy doing its own thing. You can't expect them to then recreate a system or reinvent a new system. That's really
Right, right. And the way to do that is to form a team. And by the way, that's how the ILS was invented. That's how the VOR was invented. The RTCA is actually a public-private partnership. The RTCA represents then the avionics people, but the users come and sit down, and the manufacturers come and sit down, and the FAA comes and sit down, and all together make the rules. And that's how it should be. We can't ask the FAA to invent, but we certainly could ask the FAA to guard us because they're good at that, right? Bite them if they do it wrong. And so that's how we have to do it. And the way to do it too is not to ask them to do it within today's budget. But one of the things that I'm tasked with from the AIAA is sitting with some congressional staffers this month and ask them to break out some money and send it to the FAA to help do this. But we're going to recommend this kind of thing where maybe it's chaired by NASA, or maybe this committee is chaired by AIAA or by VFS, but it's chaired by someone who has everyone's best interest in mind and not necessarily a pure governmental body. Because a pure governmental body could very well say, well, how's that go? This is Nick's all you can eat restaurant. I'm Nick. It's all you can eat.
Well, and also, I mean, then you get into what's best for my constituents and what's best for my political career and whatnot. So
That's right.
yeah. So really well said, Nick. We couldn't be more on the same page.
And if we don't get it done, if we don't have that committee, it's going to happen anyway, because you don't think Walmart and FedEx and UPS are going to sit around and not have the business. They're going to purchase the right political power and have it done anyway. Look at what happened in New York with the noise complaints from the citizens out on the tip of Long Island. They picked up, they asked the FAA many times and couldn't get an answer. They picked up the phone and called Chuck Schumer. Schumer picked up the phone and said, you know, I'm holding the FAA's continuing funding bill in my hand. Can you tell me you can fix this problem? And son of a gun, the FAA fixed the problem. And it'll happen to us. As I did the multiplication for Amazon Prime, that was only Amazon. If you took every one of the package express companies and DoorDash and all of the other people stuff, you Lyft and so on, you end up with much more than the aviation system, much more, and that in terms of economic power.
So
I think
Nick,
that's the leverage, is that the economic effects, and that's how you make the sale to
Yeah,
members of Congress and their constituents, is to say, look, we're just trying to help you, your business people, make money and make life better for your constituents.
because in the end, economics measures the societal's degree of importance. It's not that the money buys things, it's that the money represents where the public sentiment is. And if we do it right, if we made this future system proper, it would not be to carry billionaires to the opera. It would be that kids would have ambulances, or mom would get off the phone at 3 a.m. and the doctor's prescription would be sitting on her front doorstep 15 minutes later. That's the kind of service we want to have. And I think we can build it.
We take our highway system for granted in the U.S., but it's a product of the 50s, from the legislation that was passed to build the Eisenhower highway system. And before then it was you know, a lot of country roads and
Yeah.
A whole lot of time to get from A to B. And they built almost 50,000 miles of highway in the 20 years that followed that. But which completely changed the, you know, the makeup of the U.S. and the way that we do business and so forth.
That's a great observation. And
I think,
did
yeah.
you know why Eisenhower had that bug? Did you ever read that?
Yeah, I think part of it was that they wanted to actually be able to have long enough stretches of the highway to be able to use as emergency runways.
That was
Is
part
that
of it,
correct?
but also the realization they couldn't get supplies to Alaska because there was no highway. We had to build one. My uncle was one of the combat engineers that built the Alaska Highway in 1941.
Oh, wow.
But no, Eisenhower, as a young officer, rode a car from St. Louis to San Francisco and wrote the report on what it was like. And that was passed on to the military authorities because they realized they had no way to get supplies across this country. And so,
Well, and that's, yeah, what an interesting point. And to your point, some of those government supported initiatives from a connectivity perspective writ large then resulted in disproportionate economic gains for said country, right? So it's not just the government, the government function, okay, like I said, respect, enforce the laws. What does that do? Well, that creates a safe place to do business, in which case more
yeah,
business comes in. Create connectivity tissue on the two-dimensional plane that we call Earth right now, and that's the road structure. What does that do? Well, properly done, that connects distant cities in a much more efficient manner that allows commerce to more freely flow. I mean, the first example of that, well, not the first example, but a prominent in history is the Silk Road, right? Like the same thing.
yeah.
And so the economic, we do things and we use very, very carefully use some public monies, but then there's a return on investment later that is articulable and calculable, if that makes sense from a probabilistic perspective. It's most likely that this will be a positive outcome.
It does, and it's a very important point you made. And that is that if you have the proper governmental regulation, and they use regulation to mean organizing us, not telling us what to do. Then once that happens, growth occurs. And that's the trick. So if you look at, for example, the way the railroads changed the United States, it was first the railroads, then it was the interstate highways. And it was brilliant, absolutely brilliant. I don't know if you realize, I showed that map of the Manhattan. One of the guys on the commission for laying out Manhattan was Robert Fulton, who invented the steamboat. When Fulton invented the steamboat and had his boat go up the Hudson River to Albany 20 years later, St. Louis, Missouri increased its population by a factor of 10 because the boats could go up the Mississippi River and bring the supplies.
Not interesting. I'd never.
Technology runs the show. The entire human race is propelled by the technology of two main areas, transportation and medicine. I
And
think
it's interesting that following World War II, you also saw the growth of airports
Yes.
being distributed all over the US. And there was growth going into those airports until deregulation in the 70s. And suddenly, now things went the other way because it was, from a business standpoint, more affordable to make everybody drive to a regional hub and shut down all of the small regional airports.
How interesting. I gotta look at that. Thanks for that thought.
Oh
In any
yeah,
case-
deregulation has killed the regional air market, which is our focus.
Yeah.
And I think it's Brandon's focus as well.
And you see, we normally live, I mean, this is Ronald Reagan. Now, I haven't met the government, they're the problem. That's not actually true. The proper government, if it's done right, doesn't squeeze you with the regulation. They create a framework upon which growth can occur,
Mhm.
because then you can count on it.
To that framework, Nick, are you advocating then a different model of preemption? Like a regional preemption model? Because we're looking at that in the counter side a little bit with the current bill 1249 in the Senate for drones.
Wow. I don't know. I think we're out of time, but this is exactly what I would hope we would do, is to get a dialogue going. And that was Brian that made that comment? I
Yeah,
don't
well,
know.
I bring it up because you referenced the GAO report for
Right.
UAS integration earlier, and I was a part of that
Good.
that document. And so it's a tricky deal that it needs to be forward facing with multifarious players at the table, but not necessarily FAA at the head of it, in my opinion. And so I appreciated your presentation greatly.
And by the way, at the head of it, I may agree with you. I think the creativity has to occur other than in the FAA. The FAA's prime input into this should be to agree with it from the standpoint of public safety and endangerment, but not necessarily to be the inventing body. So
It's also tricky too, because there's so many players as far as aircraft are concerned.
Oh, yeah.
Spectrum is going to be, and increasingly so, is a limiting factor as well.
Yeah.
And of course, there's a real push-pull with FAA and FCC there too.
Brian, we're gonna get you involved. This is good.
Sorry, I had something come up in the middle, so I kind of came in at the tail end here. My apologies, Ben.
Well, we're about at our time. If anyone wants to connect, now's a great time to do direct messages, or just shoot me an email after the fact, and I'll be happy to connect everybody with everybody else. You should have Nick's paper in the last couple emails that I sent. And if there's any questions or connection requests, by all means, send them my way.
And Andy, you can send this presentation out to everyone if you'd like to. And I
Happy
invite
to.
personal communication, either by cell phone or by email, please. This is an open discourse, and I value everyone's inputs.
Outstanding. Nick, thank you so much for doing this. I know you're a very busy person, and I really feel like we're very lucky benefactors of your incredible background and hard work in the space. Thanks for all you've done, and thanks for all you're doing.
Your very kind words. Thank you.
Everyone,
Cheers,
thanks for
guys.
being here. Great meeting.
Great job.